Hi students, I'm back again. Let's start today with some important questions which are more likely to be asked in your competitive exams. Okay, so for that we'll start with our first topic itself, and that is some basic concept in chemistry. So let's begin with it, with the questions. The first question in this topic, let's see this question. A student performs a titration with different borates and find titer value of 25.2, 25.25 ml and 25. So average it he wants. The number of significant figure you want for the average titer value. So they wanted significant value for average titer value, for average. Now will you take it out that? So first thing what you do is, you take out the average reading. How to take out the average? Average reading. So first thing what you do is, take out the average reading. How to take out the average? You got 3 readings. So add them all. So 25.2 plus 25.25 plus 25 ml divided by 3. So now 25 plus 25, 50, 50 plus 25, 75, 75.45. So 75.45 divided by 3. So the average comes out to be approximately 25.15 ml. 25.15 ml. Now you just required to round it up. So it becomes 25.2 ml. So the average reading comes out to be 25.2. So the significant figure will be 3 of them. The significant figure is 1, 2, 3. 3 significant figure. So the answer for this question is C. We go for the second question now. The question says, which has the maximum number of atoms? 24 grams of carbon, 56 grams of iron, 26 grams of aluminium, or 108 grams of silver. Now which has the maximum number of atoms? Now how to solve this? It's very simple. Now first and foremost, we all know, if I want to find out atoms, atom is nothing else but mole multiply by atomicity multiply by Avogadro's number. Avogadro's number given by capital Na. Now you must be wondering, what is atomicity? Atomicity is the number of atoms present in the given molecules. Say for example, if I put sulfuric acid, if I take a H2SO4, atomicity will be 2 plus 1, 3 plus 4, 7 will be the atomicity. But right now in the question it is given only carbon. So atomicity for carbon will be 1. Atomicity for iron also it will be 1. Atomicity of aluminium it is 1. Atomicity of silver is also 1. Now it becomes so easy. Once you get the mole for all of them, whoever has more moles will have maximum number of atom. Let's see the moles. We'll take out the moles for carbon. So moles of carbon is the mass given, atomic mass given divided by 24 divided by 12 for carbon. It is 2 moles. Similar manner, moles of Fe will be 56 divided by 56 itself. So it is 1. What about aluminium? Moles of aluminium. Moles of aluminium is 26 divided by 27, that is approximately 1 only. Oh, moles of silver is 108 divided by 108, so 1. So tell me, who has the maximum moles? Carbon, 2 moles, and all of them needs to be multiplied by Avogadro's number. Atomicity for all of them will be 1. So the maximum mole present is for carbon. So carbon will have the maximum number of atoms. So your answer is A for question number 2. Let's see the third question. Very easy one. Law of constant composition is same as the law of conservation of mass, conservation of energy, multiple proportion, or definite proportion. So what is law of constant proportion? What does this law says? It says that any compound obtained in the nature will have the same composition whether you prepare it in the lab or you prepare it by any method. For example, if I take calcium carbonate from the earth's crust, the percentage of calcium, the percentage of carbon, the percentage of oxygen which is found in calcium carbonate will be same if I prepare calcium carbonate in the lab. So calcium carbonate can be prepared in the lab by taking calcium oxide, carbon dioxide, giving you calcium carbonate. So when you take out the percentage here of calcium, percentage of carbon, percentage of oxygen, this 2%, both the percentage will match each other. So law of constant proportion says, law of constant composition says the percentage will remain same whether you take out from the natural condition or you artificially prepare it. The same compound will have same definite proportion. So your answer for this question will be the law of constant composition is same as definite proportion. Definite proportion. So easy it is. Yeah. Now we go for the next question. Question number 4 says 0.56 grams of a gas occupies 280 cc at NTP, 280 cubic centimeter at ATP. Then its molecular mass is 48, 44.8 to 22.4. So let's see the solution for this. We all know 1 mole always corresponds to molar mass for a molecule. Molar mass, and molar mass always occupies 22400 cc at NTP, which is nearly equal to 22.4 liters. 22.4 liters. Now we want molar mass. We know that molar mass will corresponds to 22400 cc. But what is given to you? 0.56 grams corresponds to 280 cc. Now the molar mass will be equal to 0.56 multiplied by 22400 divided by 280. Remove the decimal, it will become 562400 divided by 2800. Now very simple calculation, this 00 will get cancelled. We all know 28 2s are 56. So this is 10 here, this is 2 here. So now this will become 448 upon 10, that is 44.8. So your answer for this question is B. So the molar mass is 44.8. Okay, so that was question number 4. Now we go for question number 5. Question number 5 says, if molecular weight of KMnO4, potassium permanganate, is M, then its equivalent weight in acidic medium would be. Very interesting question. Now you want acidic medium. We all know MnO4 minus 1, the oxidation state of Mn is +7. Oxidation state of Mn is +7. In acidic medium, from +7 it changes to +2. So from +7 it changes to +2. So the difference is the difference in electron. The difference in electron is equal to 5. Difference is 5. 7 minus 2. Difference is 5. So if you want equivalent weight, it is given as molecular weight divided by difference in electron. Difference in electrons. So molecular weight, they have given you M, and the difference in electron in acidic medium, you got it 5. So your answer for this question is M divided by 5. So answer is C, which is the correct answer for this in acidic medium. Now let's go to question number 6. 3 grams of oxide of a metal is converted into chloride completely, and it yields 5 grams of chloride. The equivalent weight of the metal is. Now, how will you solve this question? Very simple. Remember this relationship. Weight of metal oxide, weight of metal oxide upon weight of metal chloride is equal to equivalent weight of metal plus equivalent weight of oxygen divided by equivalent weight of metal plus equivalent weight of chloride. So it's very easy to remember. Remember, weight of metal oxide is equivalent weight of metal plus equivalent weight of oxygen. Similar manner, weight of metal chloride is equal to equivalent weight of metal plus equivalent weight of chloride. Now just substitute what all things are given to you. 3 grams of oxide of a metal, that means weight of metal oxide is given 3 grams, so put 3 here. Weight of metal chloride is been given 5, so 3 divided by 5 is equal to equivalent weight of metal. We don't know, we have to find that, so let it be represented as E. Oh, equivalent weight of oxygen, we all know equivalent weight of oxygen is 8. How you got it? 16 divided by 2 for oxygen, so it will be 8. Equivalent weight of oxygen is 8. Equivalent weight of metal I don't know, so let it be E. Equivalent weight of chloride 35.5 divided by the valency 1, so 35.5 is the equivalent weight of chloride. Now just simply solve this question and you get the value of E. When you solve this question, the value of E will be approximately 33.25 near about. So you can just make it out very quickly what will be the value of it. It can't be 3, it can't be 12, it can't be 20. So definitely the answer is A. So your answer for this question is A, 33.25. Question number 6. Now we go for the next question. So let us see question number 7 now. An organic compound has an empirical formula CH2O. Its vapor density is 45. The molecular formula of the compound is CH2O, C2H5O, C2H2O, C3H6O3. So what is the molecular formula for it? So let us see how to solve this question. First thing, how to take out molecular formula. Say molecular formula is N multiplied by empirical formula. Molecular formula is given by N multiplied by empirical formula. But question arises, what is N? How do we take out N? N is equal to molar mass divided by empirical formula mass. Empirical formula mass. So if I get N, I can straight away put it here and multiply by empirical formula. Empirical formula is given to me. It is CH2O. What I require is only N. But for N I want molar mass and I want empirical mass. So let us see how to get molar mass. Molar mass is equal to 2 into vapor density. Vd is vapor density. Vapor density is given to me 45. So it is 2 multiplied by 45, that is 90. So I got my molar mass as 90. Now I need empirical formula mass. Now empirical formula, so I know it. What is empirical formula? CH2O. So empirical formula mass will be equal to C plus 2 hydrogen plus 1 oxygen. So it is 12 plus 2 into 1 plus 16. So total comes out to be 30. So 90 divided by 30, N comes out to be 3. So you got your N now. Once you have got your N, you can put it here 3. So now just simply multiply it. So this will become C3H6O3. So your answer for this question is C3H6O3. So answer is D, which is the correct answer. Very simple to solve it. Now we go for the last question based on this topic, that is some basic concept in chemistry. So let's see a very interesting question now. Consider a titration of potassium dichromate solution with acidified Mohs salt using diphenylamine as indicators. The number of moles of Mohs salt required per mole of dichromate is. This is a redox titration, a question of redox titration. Now how will you solve this question? See, first of all, what is Mohs salt? Mohs salt is ferrous ammonium sulfate. Ferrous ammonium sulfate with 6 water molecule. This is your Mohs salt. In this, Fe is in the +2 oxidation state. +2 oxidation state. Okay. So they are asking you, if I am going to take potassium dichromate and I am going to titrate against Mohs salt, they are asking you how much moles of Mohs salt should I take to neutralize this dichromate? To neutralize this dichromate, how much moles I should take of Mohs salt? In short, I want to know how much Fe2 plus can be taken for neutralizing dichromate. So let's see how to work it out. Now potassium dichromate, the ions can be written like this: Cr2O7 2 minus. So potassium dichromate, the ionic form can be written as Cr2O7 2 minus, because there is 2 potassium, K2Cr2O7. So when I remove 2 potassium which carries positive charge, then you get chromate ion as 2 minus, dichromate ion as 2 minus. Now in acidic medium, this dichromate ion Cr, which is right now in +6 oxidation state. See, this chromium is in +6 oxidation state. It changes to +3. So tell me, what will be the difference in electron? 6 minus 3. Difference in electron is difference in electron is 3. But then there are 2 chromium. Here. So for each chromium it is 3. So therefore for 2 chromium, the difference will be of 6 electron. That means each Cr will take 3 electron. So 2 Cr will take 6 electron. So it wants 6 electron. Now come back here. Now we know that Fe2 plus, one Fe2 plus can lose 1 electron and turn into Fe3 plus. But I require 6 electron. So 1 Fe is giving me only 1 electron. So tell me, how many Fe is required to give me 6 electron? Definitely it requires 6 Fe. It requires 6 Fe2 plus. So when I take 6 Fe2 plus, then only I will get 6 electron, turning into 6 Fe3 plus. So tell me, for 2 chromium it requires 6 electron. For that I require 6 Fe, ferrous ion, 6 I require. Therefore, Mohs salt, how many moles of Mohs salt I require to neutralize this chromium is 6. So your answer for this question is D. Okay.